Hi, it's Grandma T. Welcome back to my channel. Today we're going to talk about one of the many transformations you can do with shapes on a geometric plane. The one we're going to talk about today is reflection, and it's really fun and easy. So we have our plane here, and we have our problem. We're told that square BCDE has vertices or points or coordinates B, which is a -6 and 7, C at a -2 and 6, D at a -3 and 2, and E at a -3 and 7, and that the reflection line or the mirror line or the center line is called different things in different math books. I'm not sure how your teacher would refer to it, is the y-axis, but it's that line that will be exactly in the middle of your original image and your transformed image. So whenever you are told that the reflection is along the y-axis, here's the rule that you need to follow. And if you can memorize these few little rules, it will help you with any reflection transformation you have to do. When it's along the y-axis, the mirror line is along the y-axis, we have to change every x and y coordinate into negative x and y. And I will show you how to do that. So we're going to plot the original vertices, and we're going to use this rule to get the vertices of the image. The problem they give us, or the information they give us originally, is called the pre-image, and then the new vertices will be used to form an image. These are going to be our new vertices, and I will show you how we develop those. But first, let's plot our points that they gave us originally over here. These are the four coordinate sets that will form our square. We have a -6 and 7, a -2 and 6, a -3 and 2, and a -7 and 3. And then we just draw a line to connect all of those coordinates. So to find our coordinates or vertices for the next image, for the image that we will develop, we have to do a negative of whatever our x is. Well, our x values over here just happen to all be negative, all of them. -6, -2, -3, and -7. Our y values will remain the same. And so that's why you see 7, and we had 7 over here. You see 6, and we still have 6 over here. And we have a 2, and we still have a 2 over here. And then the last y value was a 3, and we still have a 3 over here. So when I put in my x values, I have to make sure I don't forget to include my sign. We had a -6, a -2, a -3, and a -7. And as you know, a negative times this -6 is going to give us a +6. So that's how we develop this value. A negative times a -2 gives us a +2. And the negative of a -3 is a +3. And a negative of -7 is 7. So then all we do is plot those points. We plot our 6 and our 7, our 2 and our 6, our 3 and our 2, and our 7 and our 3. We connect them, and guess what? You now have an image, and you have reflected the original square BCDE with brand new points or vertices. And so that's all you have to do for that. I think it's pretty simple, but let's try some more examples just to make sure, because there are different ways to reflect a shape Here we have a triangle FGH with vertices 1 and 8, 5 and 7, and 2 and 3. So those coordinates will form our triangle. So it is reflected across y equals x. Here's the rule. When a point is reflected across y equals x, the x coordinates and y coordinates swap places. You just flip them around. So after you plot the original vertices, you use the rule shown in red to get the vertices of the image, which is our transformed shape that we will develop. And here we have 8 and 1 because all we did was flip the 1 and 8. Then we have 7 and 5 because we simply flipped the 5 and 7. And now we have 3 and 2 because we simply flipped or swapped places, and 3 and 2 is that coordinate. And then all we do is plot our points. So our original points, we have 1 and 8, we have 5 and 7, we have 2 and 3, and we connect them. To get that's our pre-image. To get our image, we plot our new set of vertices right here. We're going to plot those. We have 8 and 1, 7 and 5, 3 and 2. We connect those, and you have reflected triangle FGH. And that's all it is for that. But the important part is to remember the different rules depending on the line of reflection, the mirror line, the center line, central line, whatever your teacher may refer to it as or teach you to call it. I like saying mirror because you look in the mirror and it gives you a reflection. So Grandma T tends to say mirror line. And some geometry books as well say mirror lines. Let's work another reflection example. This time we are given the trapezoid JKLM has vertices a -4 and 3 and -2 and 7 and 2 and 7 and 3 and 3. We have those vertices. They're labeled J, K, L, and M, and we're told that it reflects across this mirror line of y equals 1. And so this will be a little different from the other two examples we just reviewed, because in this one you have to do a little work ahead of getting the points. In order to get the points, you have to do some counting. And it's really easy. You just count the number of units from those vertices, the original vertices, and you start at the mirror line, and then you will come up with the corresponding vertices. So let's take a look at what that looks like. For example, the point of -4 and 3 is going to be 2 units above the y equals 1 line. So you go 2 units in the opposite direction from the y equals 1 line, and you land on the point -4 and -1 for j prime. So you just repeat that to get the other 3 points. Let me show you what that looks like. So here we have a -4 and 3. We have our -2 and +7. We have our 3 and 3. And we have, and I'm missing one point up here. I'll make sure I add that. And so we have all of our points. This is our line that's reflected across at y equals 1. Here's our value for y right here. That's our y value, y equals 1. So this is the line of reflection. So our point here was a -4 and 3. You start at the line of reflection, and we're going to have 1 from here. We count up how many units. 1, 2. It moved 2 units. You go back to your line y equals 1, and you count the same number of units in the opposite direction, and you go 1 and 2. And that's how we got the point of a -4 and a -1 right here. For our next point, we have a -2 and a +7. We go to the y equals 1 line, we count the number of units. 1, 2, 3, 4, 5, 6. So we go back to the y equals 1 line and we count 6 in the opposite direction. We get 1, 2, 3, 4, 5, 6, and we get this point. Our next point is at 2 and a negative 5 because we start at our y equals 1 line, we go up 1, 2, 3, 4, 5, 6 spaces or units up. Go in the opposite direction, starting at your y equals 1 line. You get 1, 2, 3, 4, 5, 6. And we get the point a negative 2 and a negative 5. And now we'll do the last point. You start here, you go up 1, 2 units, go back to your y equals 1 line, go in the opposite direction 2 units, and you get this point, 3 and a negative 1. And then you join them together, and you have now reflected trapezoid JKLM across the mirror line y equals 1. So it is a little different in that you have to do some counting, and you have to be able to read and tell where these points are, what the coordinates are. -4 and -1, I can see I went over -4 and I went down to -1. That's how I got this value. So that's simple enough, I think, for everyone to understand. But if not, we can always review this in a different way, in a different video. Just let me know. I want to be able to help you understand this. I think it's fun stuff to do. Let's move on. We're going to do another reflection, and we're going to do it with a rhombus. I like that name. So the mirror line now they've told us is the x-axis. Well, here's the rule. When the mirror line is the x-axis, we change each of the xy coordinates into x negative y. So whatever we have for y, we now have to take the negative of that number. So after you plot the original points again and get your rhombus, use that rule over to the left to get the vertices of the image. So looking at the coordinates for the pre-image up here, we have 1 and 5, 6 and 3, 1 and 1, and a negative 4 and 3. So our x's will remain the same. So that's why I still have a 1, I still have a 6, I still have a 1, I still have a negative 4. But now I need to take the negative of my y value. So my 5 becomes a negative 5. My 3 becomes a negative 3. My 1 becomes a negative 1. And this 3 becomes a negative 3. And I now have the vertices of the image. And I use the pre-image vertices, the rule in the red to the left, and that's how I calculated these new vertices for my image. So let's plot the pre-image. That is what that looks like, the pre-image. Now, for our image, we're going to plot our new points. We have 1 down to a negative 5, and we get this point. And then we have 6 down to a negative 3, we get that point. And then we have 1 and a -1, and we have a negative 4 and a negative 3. And then we connect them, and that's our reflection of that rhombus. And you'll know if your graph is right by really visually and numerically. But if you remember to follow these rules, you're going to find out that this is going to be a fun thing to do. It's going to get more complicated as you get into higher math. So it's really important to understand how to do this now. All right, let's move on to the next. The next slide is also reflection, but this time it's reflected across the line x equals a negative 3. So I have drawn our mirror line on my graph so that I'll know what my starting point is, because I'm going to have to again count from my pre-image vertices to get the vertices of my image. So we are given triangle PQR with vertices a negative 2 over 3, 2 and 4, 1 and a negative 1, and it's reflected across line x equals a negative 3. So here's my mirror line. As you can see, x equals a negative 3. I find my -3. I drew a line all the way up. There's no other value for x in this particular mirror line except a -3. So let's get started. After you plot the original vertices, we're going to count again. We're going to count the number of units from those original vertices, starting at the mirror line to get the corresponding vertices for the image that we're creating. So for example, we will see in just a minute how the point -2 and 3 is 1 unit from the x equals -3 line. So we're going to go 1 unit in the opposite direction from the x equals -3 line, and we will land on the point -4 and 3, and we will repeat that to get the other 2 points for our image in our triangle. So here are the coordinates I calculated, and we're going to check and make sure Grandma T did it right. Here is one of our original coordinates, a -2 and 3. We have a +2, +4. We have a +1, -1. We draw and connect our lines, and this is our triangle. This is our pre-image. Now for our image, we're going to count. From this point, we go 1 unit from this line. So now we go in the opposite direction, 1 unit, and that gives us this point, a -4 and 3. Okay, Grandma T got that one right. Let's do this one. From the mirror line, you get 1, 2, 3, 4, 5 units that it moved. I'm going to go back to my mirror line and go 5 units in the opposite direction. 1, 2, 3, 4, 5. And I end up at a -8 and a +4. Ah, Grandma T got that one right too. All right, so now we're going to do this one. Go to our mirror line and we count 1, 2, 3, 4. So now we're going to go 4 in the opposite direction. 1, 2, 3, 4. And we end up with a -7, -1 coordinate. And those are the points for our reflected image. And that is what it looks like. So, great job. Hopefully, all of it looks pretty simple to understand. But let's do one more example just to make sure. Let's do one more reflection example. This time, it would be reflected across the line y equals a -x. And we are given rectangle MNOP with vertices of a -1 and 7, a -4 and 1, a -4 and 4, and a -7 and a -4. And again, the line of reflection or the mirroring line or center line would be y equals a -x. So here's the rule we have to follow. Whenever the y equals -x is the line, the mirror line, we have to do two things. We have to swap x and y. So our x values will become our y values, and our y values will become our x values. And we have to take the negative of whatever our original coordinate numbers are. And I'll show you how to do that, this particular example, in just a minute. So after you plot your original vertices above, we're going to use that rule to get the vertices of the image. But let's plot our pre-image. And then I'll show you how to get these coordinates for our image. Rectangle MNOP. First we have -7 and 1, -4 and 1, a -4 and a -4, a -7 and a -4, and we connect it and get our rectangle. Now, here's the part you have to remember. Grandma T forgot to swap them the first time I did it. And so my image was wrong. I'm glad I double checked my work because I found my mistake. I forgot to swap my X's and Y's, and that's what this says right here. So this -7 and 1 becomes a -1 and 7. If I took the negative of that 1, it gave me -1. I took the negative of the -7, and it gave me a +7. And so I have that one. vertex 1 coordinate pair correct. And now I have to do the next one, a -4 and a 1. So I have a -1, and then again, the negative of a -4 gives me a +4, and then a negative of a -4 twice. We're going to give me two +4s. The negative of a 4 and a -7 is going to give me a +4 and 7. And so that's how I got the vertices for my image that we will now plot. So we have -1 and 7, -1 and 4, 4 and 4, 4 and 7. And we have completed the reflection of rectangle MNOP across the mirror line of y equals or minus x. That's all I have for you today. I hope it helps you in your geometry classes. You will see more complicated transformations as you go into your higher math classes. So I hope that this helps you understand how to do transformations, and it will be a good set of skills you can use for a long time in math. I'll see you next time. Take care. Bye for now.